Assalamualaikum and hi, my name is Muhammad Adam bin AZZIZI and my registration number is 01D32YF1002. And today we will present our problem-based task that we completed together. Mohaimin, EZZAT, KHAIRUL and I are the only members of our group.
Assalamualaikum warahmatullahi wabarakatuh. My name is MUHAIMIN ZALANI. My magic number is 01T21F151. So today I would like to present about problem-based task, question 1. So the first question is the characteristic between single mode and multi-mode fiber optic cable in terms of core diameter, like propagation, attenuation, and application. Now we jump to the main slide, which is single mode slide. Single mode core diameter is 9/125 nanometer, which is the fastest and the smallest core diameter. Like propagation using a laser or laser diodes. Attenuation 1310 nanometer, about 0.36 dB per kilometer, or by using bandwidth 1550 nanometer, then attenuation is 0.22 dB per kilometer. So usually apply in telecommunication, long haul or high data rate system. After that, multi-mode step index. So core diameter is 15/135 nanometer until 200/135 nanometer, which is the last core diameter. Like propagation using LED, like emitting diode, and V cells, which is vertical cavity surface emitting laser. Attenuation by using bandwidth 850 nanometer, usually 3.0 dB per kilometer, and apply in communication over short distance, example building or campus. And then next slide, multi-mode graded index. Core diameter is 65/135 nanometer. Like propagation using same like the step index, LED and V cells. The attenuation by using 1300 nanometer bandwidth. Usually the loss 1.0 dB per kilometer, and apply in a communication over short distance, example building or campus. So usually telecommunication will use graded better than step index, because the difference speed, the graded is more fastest, more than the step index. Thank you.
Okay, thank you. Okay, next we will continue with question 1.2. So in question 1.2, the question have given us the incident angle of the fiber 38, the index of refraction of core and cladding 1.48 and 1.25 respectively. Then lastly, the index of refraction for air is 1.00. So the question wants us to calculate the refraction angle at air core interface, the critical angle at the core cladding interface, the numerical aperture, and lastly the accepted angle for the multi-mode fiber optic cable. Okay, so here are the solutions that I have come up with. First, we will start with refraction angle at air core interface. So for this, the solution is I have used the Snell laws formula. So the answer that we got from using Snell law is 6.64 degree. Next, we will continue with critical angle at the core cladding interface. So for this, we will use the formula for finding critical angle. It is similar with the Snell's law formula. So the answer we got from using the formula is 57.63 degree. Next, for the numerical aperture, we will use the numerical aperture formula. So the answer we got from using the numerical aperture formula is 0.79. Lastly, to find the acceptance angle, we will use the acceptance angle formula. So from the formula, this is the answer we got, 52.19 degree. Okay, so that's all from me. Next, we will continue with question 2. So I will pass this presentation to EZZAT.
Assalamualaikum and very good morning. My name is Muhammad AZZIZI. My matrix number is 01DDT21F1078. Right now, I will present for the question 2. Question 2. Wavelength division multiplexer WDM is one of the techniques in optical frequency division multiplexing. Explain the concept of WDM and build WDM block diagram. So what is WDM? WDM is a wavelength division multiplexing. WDM is a technology that increases bandwidth by allowing different data streams at different frequencies to be sent over a single optical fiber network. Signals at WDM wavelengths are independent from each other. Next is the basics of wavelength division multiplexing, WDM. Wavelength division multiplexing, which is WDM, has long been the technology of choice for transporting large amounts of data between sites and optimize optical network performance. WDM with example. Wavelength division multiplexing WDM is a technique of multiplexing multiple optical carrier signals through a single optical fiber channel by varying the wavelengths of laser lights. WDM allows communication in both the direction in the fiber cable. So, last but not least is the example of WDM block diagram. From multi-transmitter connect into one WDM multiplexer, go straight through optical amplifier and then arrive at D marks and then return to the normal receiver.
Assalamualaikum warahmatullahi wabarakatuh. My name is HAFIZI bin Abdul Basit. My matrix number is 01DDT21F1056. Now I will continue with about passive optical network. Okay, for the problem-based task, for the question 3, passive optical network system utilize a passive splitter that takes one input and split it to broadcast signal downstream to many users. Illustrate basic PON architecture, terminate diagram with different type of fiber loop. Okay, I will explain about passive optical network. Passive optical network is a fiber optic network utilizing a point-to-multipoint topology and optical splitter to deliver data from a single transmission point to multiple user endpoint. Passive in this context refers the unpowered condition of the fiber and splitting combining component. Okay, this is the diagram example passive optical network. So how does a passive optical network works? A PON system consists of an optical line terminal or LT at the communication company, central office and several optical network unit near end user. Typically up to 32 ONU can be connected to a single optical line terminal. The word passive simply describes the fact that optical transmission has no power requirement or active electronic part once the signal is being transmitted across the network. This image show how redundant optical line terminal hardware commonly sit in the telecom service provider central office. From there, fiber cabling is distributed up to 20 kilometers from the central office and is split into multiple ONU using a passive optical splitter which terminate the fiber connection close to the customer demarcation point. So the ONU will then deliver a network handoff using copper or fiber internet cables, making it easy for customer to connect to their existing local area network.
Okay, so that sums up our presentation for today. That is all from us. Thank you for watching.